So we're going to look at dot product today. So they tell me that if you want to find the dot product of two vectors that are in component form, that you can multiply the dot product by doing the product of the first value of each vector plus the product of the second value of each vector. So for instance, if I have u is -1, 3, and I have v is 2, -4, and I want to find their dot product, I'm just going to say -1 times 2 and 3 times -4. And then I'll just add those two products. So I'll get -14. So that's how I find dot product. Now, on page 658, they give me some properties of dot product. And I know sometimes these boxes, you have a tendency to just kind of brush over. But a lot of times, they'll save us a lot of time and energy. And that's the case with the one on 458. The first thing they tell me is that u dot v is the same thing as v dot u. So if you have, it's like 2 times 3 is the same thing as 3 times 2. You can multiply dot product in any order. Second thing it says is that if you have the 0 vector, the dot product of the 0 vector and any other vector is always going to be 0. Third thing they tell me there is basically distributive property works. If you have u dotted with a sum, v plus w, you can distribute that and say u dot v plus u dot w. The fourth one says that if you have a vector dotted with itself, it's just going to be its magnitude squared. And then number 5 says if you have a constant times a dot product, you really can do that in any order. Like you could do the constant times u and then dot it with v, or the constant times v and then dot it with u, or u dot v and then multiply by the constant. So just several different ways that we can change up our dot product. So when we go back to example 2, and these little numbers out here in the margin are the homework problems that correspond to the example. When we go back to example number 2, they asked me to find v dot u and then multiply that by w. Now, if I know that first property right there, that u dot v is the same thing as v dot u, I don't have to do another dot product. I can just say, okay, since v dot u is the same thing as u dot v, I already know that's -14. It wouldn't be wrong if I did the dot product of v and u. I'd get -14 again. I'm just saving myself some time and hassle. All right, so now I'm back to scalar multiplication that we did yesterday. Take that -14 and multiply it times the vector. So I would end up with -14 times 1 and -14 times -2. All right, the third thing they show me there is to do u dot 2v. And according to that last property that we just looked at when you had a constant or a scalar being multiplied by a dot product, we said that you could do the dot product first and then multiply by the scalar. So again, I've already found the dot product of u and v to be -14, so I save myself the work and just say 2 times -14 is -28. Again, if I had done the scalar 2 times the vector v and gotten that component form and then dotted that with u, I would have gotten the same answer, just saving myself some work.